Put your dollar, equal sign, float function, input function, close open parenthesis, and put inside, enter the amount of dollar, space. The second line, your quarter, the value quarter is dollar divided by 0.25. And for dime, the value of dime is dollar percent, 0.25 divided by 0.10. And for nickel, dollar divided by, or I mean, percent of 0.25, percent, sign again, 0.10, and then divided by 0.05. And for penny, percent dollar, percent of 0.25, percent again by 0.10, percent of 0.05, and divided by 0.01. We're gonna print it. Print quotation mark, the number of points for comma dollar, comma again, quotation mark or colon. Gonna print close open parenthesis, the value of quarters, colon, comma, and then quarter. We're gonna copy paste it for so we can easily type. And I change it by dimes, change it by nickels and pennies. Also here, put the value of dime, value of nickel, and the value of penny. In order to get the smallest number, we put the smallest useful number, equal sign, and use the main function to get the minimum number inside the parentheses. Put your quarter, dime, nickel, and pen. And print it, print, quotation mark, smallest number of coins, then represent, comma, dollar, then comma again, quotation mark, dollar sign is, comma again, then smallest num. Then second row. Put here 1.56, enter. The surface area of a spherical tank is 2,000 square meter. Solve the volume of a sphere. So the first line we're gonna from import. We're gonna import square root, and in the second line we're gonna type the variable a plus sign. We're gonna use float function. Close open parentheses. We're gonna put inside input. Close open parentheses, and we're gonna and ask the user to enter the surface area of a sphere. Colon then space. The third line, we're going to put here the value of pi. Pi is equal to 3.1460. In the fourth line, because the radius is not given, we're going to use the formula of surface area to get the radius. Because the formula of surface area is 4 pi r squared. So put here 4 pi is equal to flow, close open parentheses, 4 asterisk sign, which represent multiplication, multiplied to the value of pi. And in the fifth line, we're gonna type here r, which represents the radius. R is equal to square root, close open parentheses, square root of surface area slash represents divide or division divided by 4 pi, which is the product of 4 and the value of pi. To get the volume, we're going to use the formula of volume of a sphere, which is 4/3 pi r cubed equal p cosine 4/3 story sine multiplied value of pi multiplied to r multiplied to r cubed. We're gonna print it. Print quotation parenthesis quotation mark the volume of a sphere is equal sign then comma and we're going to put the v which is the value and we're going to try to run the code. We're going to enter the surface area which is 2000 square meter. So the volume of sphere is 8410. Problem number 3. Find the volume of right circular cone of radius 5 meters and the height 6 meters. So on the first line, we're going to put here r, which represents radius, cosine, space, slope function, close open parentheses. When I use input, we ask the user to enter the radius, quotation mark, colon, then space. The second line, we're going to type here h, which represents the height, the cosine, slope function, close open parentheses. We're going to put 2 to ask the user to enter the height, close open parentheses, quotation mark, colon, then space. In the third line, we're going to put here the value of pi, which is 3.1416. And in the fourth line, we're going to put here V, which is the volume of right circular cone. And the formula in getting the volume is pi r squared multiplied to h divided by 3, which is the height. So equals sign, space, pi, asterisk sign, which represents multiplication, multiplied to r squared, then asterisk again. So multiply it to h divided by 3. I use slash to represent division. And we're going to print it. Print, close open parentheses, quotation mark, the volume of a right circular cone is equal sign, then comma, in space, V, which represents the volume. And we're going to try to run the code. We'll put here 5, then 6 is the height. And this is the volume of a right circular cone. So in the first line, we're going to assume H, that it is the length, the width, and the height. So in the first line, we're going to put here L, which represents the length, equal sign, space, float function, close open parentheses, then input function for the user to input the value of length, quotation mark, and ask the user to enter the length. Colon, then space. For the second line, we're gonna put here W, which is the width, equal sign in space, float again, float function, input function, close open parentheses, quotation mark, enter the second number, colon, and then space. For the third line, we're gonna put here h, which is the height, float function, close open parentheses, input, ask the user to enter the third number, colon, then space. To get the volume, we're gonna multiply the three of these and divide each one of them by 100 to convert it into cubic meter. So we'll put here length divided by 100 space asterisk sign, which represents multiplication, with divided by 100, which represents by backslash, asterisk again, height divided by 100. And we're gonna print it. Print, close open parenthesis, quotation mark, we're gonna put inside the volume open top box is equal sign, comma, and then space, volume, comma again, and then quotation mark, and we're gonna put inside the unit, which is cubic meter. And we're gonna try to print the code. Enter the first number. The first number is 200. The second is 300. And the third is 50. So this is the volume of an open top box. So in the first line, we're gonna put here final velocity FB space cosine float function close parenthesis input function to ask the user to enter the final velocity. Comma and space. In the second line, we're gonna put here t, which is the time float close open parenthesis input function close open parenthesis again quotation mark ask the user to enter the change in time colon then space. In the third line, we're gonna put here a, which is the acceleration, equals to float close open parenthesis final velocity. We're gonna multiply it to 1.6 to convert it into kilometer per hour slash, which represents division. We're gonna divide it by time. We're gonna divide time by 3,600 to convert it into hour. And we're gonna print it. Print close open parenthesis quotation mark total is equal sign comma and space a, which is the acceleration, space again quotation mark. We're gonna put inside the unit, which is kilometer per hour squared. And we're gonna print and run the code. Final velocity 120. Finishing time is 10. So here it is. We're gonna use the formula 1/2 times g t squared. So in the first line, we're gonna put here t space cosine float function close open parenthesis input close open parenthesis again quotation mark. We're gonna ask the user to enter the time colon then space. In the second line, we're gonna put here g, which represents the acceleration due to gravity. Float close open parenthesis input function close open parenthesis. Enter the acceleration due to gravity colon and space. In the third line, we're gonna put here t2, which is t squared cosine space. And to get the height, equal sign space 1/2 asterisk sign to multiply it to gravity, which is represented by g asterisk sign again close open parenthesis t squared or t2. And we're gonna print it. Print close open parenthesis the height of the building is put here comma, space, H, comma again, then space, and the unit of measurement is meter. So we're gonna print it. The time is 8 seconds. Acceleration due to gravity is 9.8. And this is the height of the building. And to get the velocity of the body as it hits the ground, we solve it from math. We'll import square root. The height of the building, which represents by h equals to 313.6 meters. And acceleration due to gravity, which is equal to 9.8. To get the final velocity, the formula is square root of 2gh. Final velocity for some space, and I use square root function. Close open parentheses, we're going to put inside 2 asterisk sign to multiply it to the gravity, multiply it to the height. And we're going to print it. Print, close open parentheses, quotation mark, the velocity of the body hits the ground is equals 9, then comma, final velocity, comma again, and the unit of measure is meter per second. So we're going to run the code. So this is the velocity of the body as it hits the ground. In the first line, we're going to import SymPy. Import SymPy. And then I put here x variable equals to symbols, close open parentheses, when I put inside as x, and when I type here the function, which is x raised to the power of 2 minus 25 divided by x minus 5. And when I type here the limit of f, x as approaches 5. And we're going to try to run the code. I use lowercase of l to solve the value of a limit, and if I'm going to change it to uppercase, it will display the expression. First line, we'll put your x equal to x point a equal to -2, 0, and I forgot to import from fractions, import and point b equal to close open parentheses, quotation mark, 3 and 6. Y sub 1 is equal to 0, y sub 2 is equal to 6, x sub 1 is equal to -2, x sub 2 is equal to 3, 2 minus y sub 1 divided by x sub 2 minus x sub 1, and equals to, when I use your fraction to get the fraction y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, and b, initial b, equals to multiply m multiply by 3, and to get the b equal to negative float function, cosine says y sub 2 minus the initial. We're gonna print it. Print y is equal to comma and then m comma then x, then comma, and then put here, insert here plus sign, then comma, and then b. I'm gonna print it. So why? Because